Right now, roughly 650 light-years away in the constellation Aquarius, there is a dead star surrounded by its own corpse. The gas it shed over the final 10,000 years of its life is still glowing, still expanding, still cooling into the vacuum. And from our vantage point here on Earth, that expanding cloud of gas looks exactly like a giant eye staring back at us from deep space. You have probably seen the image. It has been circulated millions of times. People call it the Eye of God. Some call it the Eye of Sauron. And every time the image resurfaces, the same claims follow, that NASA has captured something biblical, that it looks too perfect to be natural, that ancient prophets described exactly this kind of structure thousands of years ago. Those claims are not true. But here is what is true, and it is far stranger than any of those stories. That dead star is a preview of what will happen to our own sun. And in January 2026, the James Webb Space Telescope pointed its infrared camera directly at it and revealed something inside the eye that no telescope had ever been able to see before, something that was not predicted by any model, something that, even now, scientists do not fully understand. Stay with me on this one because the real science behind this image is more extraordinary than anything the clickbait versions of this story have ever told you. Subscribe now if you want more stories like this because we are just getting started. Let's go back to where this story actually begins. In 1824, a German astronomer named Carl Ludwig Harding pointed a modest telescope toward the constellation Aquarius and noticed a faint, hazy patch of light. He cataloged it. That was it. No dramatic discovery moment, no press conference. Just a dim smudge in the eyepiece that most astronomers at the time would have glanced at and moved on from. It was assigned the designation NGC 7293 and classified as a planetary nebula, a name that is itself a mistake. William Herschel coined the term in the 1700s because through early telescopes these objects looked like the faint disks of distant planets. They have nothing to do with planets, nothing at all. For the next century and a half, the Helix Nebula was treated as a reasonably ordinary object, a dying star surrounded by a shell of expelled gas. Beautiful, yes, but well understood, or so everyone thought. Then in the 1950s, astronomers at Palomar Observatory took deeper photographs and noticed something unexpected. The smooth ring was not smooth. It was made of thousands of tiny, dense, comet-shaped structures radiating outward from the central star like the spokes of a wheel. Nobody had predicted those structures would be there. Nobody had a model that produced them. And when the Hubble Space Telescope turned its cameras on the Helix in 1994, it did not just confirm those structures. It revealed that there were thousands more of them than anyone had guessed, packed along the inner rim of the nebula in staggering numbers. Astronomers gave them a name: cometary knots. And from that moment, the Helix Nebula stopped being an ordinary planetary nebula and became one of the most studied objects in the sky. For decades, the standard model of how a planetary nebula forms described a relatively simple process. A star like our Sun runs out of hydrogen fuel. Its core contracts. Its outer layers expand. Over thousands of years, those outer layers drift into space, forming a roughly spherical shell of gas. The exposed core, now a white dwarf with a surface temperature exceeding 100,000 Kelvin, floods the surrounding gas with ultraviolet radiation. The gas glows, the shell expands, eventually it fades, clean, elegant, predictable. The Helix Nebula broke that picture. When the Hubble Space Telescope captured its first detailed images in the 1990s, astronomers expected to see a simple, expanding shell. What they found instead was a structure so complex that Robert Odell of Vanderbilt University, one of the leading researchers on the Helix, had to fundamentally rethink the geometry. The nebula was not a simple ring. It was a trillion-mile-long tunnel of glowing gas, and we happened to be looking straight down the barrel of it. That is why it looks like an eye. Not because of design, not because of intention, because of geometry. We are staring down a tube of expelled stellar material, and the ring we see is the circular cross-section of that tube illuminated by the dying star at its center. Now stop and sit with that for a second. The most shared, most mythologized image in popular astronomy, the one people point to as evidence of the divine, is a perspective illusion. We are looking at a cylinder from one end. If we could travel a few hundred light years to the side and look at the helix from a different angle, it would not look like an eye at all. It would look like an elongated barrel of gas with a faint white dot at its center. But here's the detail that tends to stop people in their tracks. Inside that barrel, there are approximately 40,000 cometary knots. Each one has roughly the mass of the Earth, and each one spans a volume several times the size of Pluto's entire orbit around the Sun. Think about that. Structures with the mass of a planet spread across a space larger than our entire solar system, and there are 40,000 of them packed into the inner walls of this one nebula. Their existence was not initially predicted, their origins are still not well understood, but here is the part of this that stops being abstract and starts being personal. The Helix Nebula is not just some exotic object in a distant part of the galaxy, it is one of the closest planetary nebulae to Earth. And the star that created it was a star very much like our Sun, same general mass range, same evolutionary pathway. What the helix shows us is not a curiosity, it is a prophecy. In approximately 5 billion years, our Sun will exhaust the hydrogen in its core, swell into a red giant large enough to swallow Mercury and Venus, and then shed its outer layers into space. What remains will be a white dwarf roughly the size of Earth, but containing about half the Sun's original mass. A teaspoon of that material would weigh several tons. And around that white dwarf for about 10,000 years, there will be a planetary nebula, our nebula, made from the same atoms that right now are part of this solar system. We do not yet know exactly what shape our nebula will take, whether it will form a tube like the helix or a butterfly like NGC 6302 or something else entirely. But the fact that we can look at the Helix Nebula and say with scientific confidence, this is what our Sun's death will look like, that is a connection between a distant object and our own existence that no amount of mythologizing can improve on. The real story does not need embellishment. In January 2026, the James Webb Space Telescope released a new image of the Helix Nebula that changed how astronomers see this object. Previous telescopes, including Hubble and the Spitzer Space Telescope, had captured the helix in visible and infrared light, but Hubble's view of the cometary knots showed them as a kind of haze, a texture along the inner rim that hinted at structure without fully resolving it. Webb's near-infrared camera cut through that haze entirely. What had been a blur became a forest. The JWST image shows thousands of individual cometary knots rendered in extraordinary detail, streaming outward from the inner shell like pillars of fire. Each knot has a bright, dense head, illuminated and ionized by the ultraviolet radiation from the central white dwarf. Trailing behind each head is a long tail of cooler gas, pointing away from the star like the tail of a comet. The colors in the image are not decorative. They encode real physics. Blue tones close to the center mark the hottest, most energized gas, stripped of electrons by intense ultraviolet light. Yellow tones further out indicate regions where hydrogen atoms have bonded into molecules. At the outer edges, reddish hues trace the coldest material, where gas thins and dust begins to dominate. What Webb revealed is the sharp boundary where fast-moving hot gas from the dying star slams into the slower, cooler shells of material that were ejected earlier in the star's life. Astronomers had theorized about this boundary for years. Webb showed it with a clarity that made astrophysicist Jessie Christiansen write that she thought she was looking at a close-up of lavender until she noticed the background galaxies. If you are the kind of person who wants space stories grounded in real science instead of dressed up in mythology, drop a like on this video right now because it genuinely helps this kind of content reach more people who would appreciate it. Here's what makes the cometary knots genuinely mysterious. We know they exist. We can see them in astonishing detail now, but the mechanism that creates them is still debated. The leading hypothesis is that they form when the fast, hot stellar wind from the white dwarf crashes into denser clumps of material that survived the initial ejection. Those clumps resist being swept away, and the wind sculpts tails behind them, like water flowing around rocks in a stream. But that model does not fully explain the numbers. 40,000 knots. Matsuura and colleagues estimated that figure in a 2009 study, and it remains one of the highest counts of any planetary nebula. Where did all those dense clumps come from? Were they pre-existing structures in the star's outer layers, embedded there during the red giant phase? Were they fragments produced by instabilities in the ejection process itself? The answer is still being worked out. And here is the detail that adds another layer of strangeness. The Helix Nebula's white dwarf has been producing an unexplained X-ray signal for over 40 years. Chandra X-ray observatory data confirmed the signal. And for decades, astronomers could not figure out what was generating it. A white dwarf this old and this far along its cooling track should not be producing X-rays at this level. One hypothesis published and discussed in scientific literature is that a planet or large body was tidally disrupted by the white dwarf, torn apart by gravitational forces as it spiraled too close. The debris from that destruction could be producing the observed X-ray emission. If confirmed, it would be the first evidence of a planet being destroyed during the planetary nebula phase of stellar evolution. Think about what that means. Not just a star dying, a world dying with it, pulled apart by the same gravitational forces that once held it in orbit. The helix would not just be a tomb for a star, it would be a tomb for an entire planetary system. There is a word for what happens when the human brain sees a meaningful pattern in something random. It is called pareidolia, and it is one of the most well-documented phenomena in cognitive psychology. The fusiform face area, a specialized region in the temporal lobe of your brain, is tuned so aggressively to detect faces that it fires even when no face is present. 2 dots above a curved line, an electrical outlet, the front end of a car, a nebula 650 light years away. Your brain treats all of them the same way. It sees an eye because it cannot help seeing an eye. Evolutionary psychologists argue this trait was essential for survival. Mistaking a bush for a predator costs you a moment of calm. Mistaking a predator for a bush costs you your life. So the brain evolved to overdetect, to find faces even when there are none. NASA itself has a page dedicated to pareidolia in astronomy. The face on Mars, captured by Viking 1 in 1976, triggered decades of conspiracy theories until higher resolution images revealed it was just a mesa with convenient shadows. The Horsehead Nebula, the Pillars of Creation, the Crab Nebula. We name these objects after what they look like to us, not after what they are. And that instinct, the instinct to see design where there is physics, to see intention where there is process, is the same instinct that produces every viral claim about NASA capturing angels in space. The Helix Nebula is not an eye. It is not a divine being. It is not evidence of anything supernatural. It is something far more remarkable than that. It is the remnant of a star that lived for billions of years, converted hydrogen into helium, helium into carbon and oxygen, shed its atmosphere into the interstellar medium, and left behind a core so dense that the atoms inside it are pressed together until only quantum mechanical pressure prevents further collapse. The carbon and oxygen in that white dwarf, the same elements that make up your bones, your blood, your DNA, were forged in the nuclear furnace of a star that is now dead. The helix is not watching us. It is showing us where we came from and where our own solar system is headed. Now let's talk about what is happening right now in 2026. The JWST helix image, released on January 20th, 2026, is already being used by research teams to study the temperature gradient across the nebula with a precision that was previously impossible. The sharp transition from ionized gas to molecular hydrogen to cold dust, visible for the first time in Webb's infrared view, is giving astronomers new data on how stellar winds interact with previously ejected material. The cometary knots are being studied individually now, not just as a population. Researchers are mapping their internal structure, measuring their molecular composition using instruments like ALMA, and trying to determine how long they will survive before they photoevaporate entirely. The Helix Nebula itself will not last long in cosmic terms. Planetary nebulae are temporary. The gas is expanding, thinning, cooling. Within roughly 10,000 years, the nebula will have faded completely, dispersed into the interstellar medium. The white dwarf will remain, slowly cooling over trillions of years, but the glowing shell that makes the helix so photogenic will be gone. We are seeing this object during a brief window, a 10,000-year snapshot in a process that spans billions. Here is what I want you to take away from all of this. The Helix Nebula does not need to be an angel to be extraordinary. It does not need to be supernatural to be profound. The fact that a star very much like our own sun lived for billions of years, died, and left behind a structure so complex that the best telescopes ever built are still struggling to explain parts of it, that is the story. The fact that we can look at it and say with certainty, this is what the sun will do, this is what will happen to the atoms in our solar system, that is the connection to our lives. Not mythology, not pattern recognition run wild. Chemistry, physics, stellar evolution playing out in real time, 650 light years away, visible to anyone with a pair of binoculars and a dark sky. The next time someone shares that image and tells you NASA photographed an angel, you will know what you are actually looking at. The death of a star, the birth of raw material for future worlds, a trillion-mile tunnel of glowing gas seen from one end, and a reminder that the universe does not need to be designed to be beautiful. It just is. If this changed how you see the Helix Nebula, subscribe and turn on notifications because we cover stories like this every week, the ones where the real science is more extraordinary than the myths people build around it. Drop a comment and tell me what surprised you most, whether it was the cometary knots, the perspective trick, or the fact that this is a preview of our own sun's future. And share this with someone who has seen that image and believed the angel story because they deserve the real version. It is better.